is a honors pre-algebra final exam that I found online. It was like Praireview, Texas or something of that nature. And I liked it just because it was pretty thorough. However, it's got some issues, some problems, some mistakes in it, but doesn't mean that we can't use it. I like the word problems. A league of 5 soccer teams, we found a mistake in the first one also, by the way. A league of 5 soccer teams has numerous games postponed because of bad weather. On February 1st, the teams are 42%, 1/3, 2/7, 61%, and 3/5 of the way through their scheduled games. Which list shows the completion rates in order from least to greatest? So you have 5 teams, and those 5 teams are 42% done, 1/3 of the way done. Another team is 2/7. One team is 61%, and then your 5th team is 3/5 of the way. So we have percents, we have fractions, and we have to convert them to a consistent value. We see that in each of these, unfortunately, there is no 6, well, there is a 60%, but each of these is meant to say 61%. They made a mistake there. So understand that that is not 60%, that this really should be 61%. That's first thing. So let's turn them all to decimals. I like always converting to decimals. So 42% is 0.42 as a decimal form. Decimal points there. In order to convert a percent to a decimal, you move it 2 places to the left. Reason being, 42% is equal to 42 over 100. 42 out of 100%. So that's how we get that. 42 over 100 is 42 hundredths, and 0.42 is 42 hundredths. So a couple ways of figuring that out. 1/3, everybody should know that that is 0.3 repeating. You shouldn't have to use a calculator. There are certain decimals that you should, or certain fractions that you should be able to convert without a calculator. 2/7 is not one of them. That is a non-terminating, non-repeat. Oh, no, it's repeating. So 2 divided by 7 gives you 0.2857114, 2857114, and it keeps repeating and repeating. 0.2857114 would be written, not the repeating over there, because the next it would continue 2857114, 2855714. So we can know that 61% as a decimal is 0.61, and 3/5 is another one of those fractions that you should know what its decimal form is. So if we were going to put those in order from least to greatest, we have to be aware of what order it needs to be in. So we're going to go in the ones place, or the units, and we see that everyone in the ones place, the units place, is a 0. So we can't determine anything. So now we're going to go to the tenths place. So the tenths place gives us this. Which one is the smallest? Well, this is going to be our smallest. That's going to be our first number. So we're good. Now let's go to the 3/4. So we have 0.4. That's going to be our second largest. And then, oh, sorry, that's not true. 0.3 repeating is our second. Our next one is going to be 4. And then we tie with 6. So we need to understand so we're going to have to go to the next place value. So we're going to have to go out to the hundredths place. And going from smaller to bigger, this would be our 4th largest. And then we have our 5th. So in order, it goes 2/7, smallest. Next is 1/3. then 42%, then 4 is 3/5, and then fifth one is 61%. So if we had to look at those, which one of those is in that order, 2/7, 1/3, it would be A. So our correct answer for number 1 would be A. Let's do it in green. So A would be the answer, understanding that it's really not 60%. Good. Number 2, the local cable company carries 25% movie channels, 14% educational channels, and 20% sports channels, and 41% family channels. If Caitlin randomly turns on a channel, which equation below can be used to determine the probability of Caitlin's channel being a sports channel? X out of 170 channels that the cable company carries. So if we're going to do this, it's going to be, so we have X represents the number of sports channels. So this is out of 170. So those are channels. And then this is percent. So we notice that we have percent. So sports is 20%. So we're going to have the part over the whole. So the part is going to be 20 for sports. And this is my percent. 20 over 100 is going to be equal to, well, we have 170 channels. These are channels. And then we want to know how many does 20% of 170. So it's going to be 20 over 100 equals X over 170. And that, again, is going to be A. So that's how I see that. You always should think of fractions as part over the whole or the total. And that looks pretty good. Number 3, the sun is approximately 93 million miles away from the Earth. How is this number of miles correctly expressed in scientific notation? We know that scientific notation is going to be between 1. It can be your number. This is your number. Well, maybe we'll do n is less than 10. So it can be equal to 1, but it can't be equal to 10. So it has to be a single digit. It has to be in the ones place. So we have 93 million, and it's currently, the decimal point currently is right here. And so we're going to move this decimal place until this number is between 1 and 10. So if I move it 1 place, it's 9,300,000. If I move it 2 places, it's 930,000. If I move it 3 places, we're at 93,000, 9,300. 930, 93, 9.3. So now it's lying between 1 and 10. So we have to be able to see how many decimal places did I move, and understand that each decimal place is a value of 10. 1, 2, 3, 4, 5, 6, 7. So I moved 7 spaces, 7 tens. So I would write it as 9.3 times 10 to the 7th, because there were 7 tens that I represented as I moved to make the bigger number smaller. So we started off with a really big number, and now we have a really small number. So where did the bigness go? Well, the bigness, this is my small, it went and became a small number, but it still has to be equivalent to this. So where did the bigness, where is the bigness represented? This is where the bigness is represented, 10 to the 7th. We know that 10 to the 7th is 1 with 7 zeros. So that's the proper way of writing it in scientific notation. 9.3 times 10 to the 7th, and, oh my goodness, A again. Yeah, it's kind of, they're big on the letter A for some reason. A recipe for cookies calls for 1 1/3 cups of milk, 2 1/2 cups of flour, and 1 3/4 cups of other ingredients. How many total cups of milk, flour, and other ingredients are needed to make 24 cookies? So we have to make twice the batch. So this is one batch for the ingredients for one batch, and 24 cookies represents 2 batches. So we're going to add 1 1/3. Probably don't want to do it in green. Let's do it in black. 1 1/3 plus 2 1/2 plus 1 3/4. There's a number of ways of adding these. I like turning them into improper fractions. 5/2 and 7/4. So 3 times 1 plus 1 gives me 4. 2 times 2 plus 1 gives me 5. 4 times 1 plus 3 gives me 7. That's the nice way of turning a mixed number into improper. I am a big improper fraction guy. In high school, teachers in college, teachers are big into improper. Now we need a common denominator. We have 3 different denominators. We have 3, 2, and 4. So we want to find the least common denominator. You should be able to see that. Multiples of 3, 6, 9, 12, 15, 18. Those are multiples. 2 is 2, 4, 6, 8, 10, 12, 14, 16, 18. And 4 is 4, 8, 12, 16, 20, 24. Oh, we should maybe go out there. Let's do that. We can keep going, extending it a little bit. 18, 21, 24, 18, 20, 22, 24. So we want to look for common multiples. So the first common multiple we can see that they share is 12. Another common multiple they share is 24. But 12 is my LCM and 24 is just a common multiple. So we want to do LCM. You could do common multiple, but LCM tends to be more easier because smaller numbers. So now we have to find conversions. So we're finding equivalency. 4/3 is equal to how many 12ths? You see that, 4/3. So we're going to multiply 3 times 4 to get 12. So if we want it to be equivalent, we're going to have to multiply by the same number. So we get 16. And if we have 5/2, so now we're going to convert or find an equivalent fraction. So you ask 2 times what is 12? 2 times 6. So we're going to multiply by the same number. That makes 30/12. Or you can ask, 4 goes into 12 3 times. 3 times 7 is 21. And now we're going to add them all together. So 16 plus 30 plus 21 is 67/12. I think that is. That's 3, 5, 6, yep, 67. And then we're going to double it. We're going to multiply it by 2. Why? Because there are 2 batches. Now, Mr. Mack, why didn't you turn it into a mixed number? Because I got to double it. And the reason why I'm doubling it here is I'm going to cross cancel. I did not multiply 67 times 2 and then over 12. I'd much rather do the more efficient way of reducing prior. So 2 goes into 2 once, 2 goes into 6/12, 12 times, or 6 times. So we get 67/6. That's how much of the ingredients you need. Now we can turn that into a mixed number. 67/6 is 11 1/6 cups of ingredients is needed. So that's how I would do number 4. It's just I don't know. To me, that's the easiest way to do it. All right, number 5. Which equation can be used to find h the number of hours in a day. We know that there are 24 hours per day. So if we take 24 and multiply it by the number of days, we're going to get the number of hours in that number of days. We can also look at it as days and hours. 0 days, 0 hours. 1 day, 24 hours. 2 days, 48 hours. 3 days, 72 hours. And so we know that we're going to multiply the number of days times 24, because that's how I was getting that. So 24 times D gives me the number of hours. Category 2, patterns, functions, and algebra. Jeremy runs a steel mill. To make a certain steel, 3 pounds of titanium is alloyed with 150 pounds of iron. If Jeremy wants to make that same steel using 4.3 tons of titanium, which equation can he use to find the number of tons of iron he must procure? So we have this, what would we call it? It's not conversion. We have this ratio, or a scale. We see this in scaled units. So it's the ratio for the type of iron. And he has titanium and he has iron. So let's do the ratio. Let's see how much titanium he uses. 3 pounds of titanium and 150 pounds of iron. So make sure that they're using the same units too, okay? And that's going to be equal to, this is situation 1, that's the ratio situation, and then situation 2 is when he has 4.3 tons of titanium. How much iron does he need? So you would write it in that fashion. So any way of that. So we're looking and we see C, 4.3. So these are all equivalent. It's just ratios, and that's going to be titanium over iron. Good? So number 7, Shaneka pays $33 for 22 pounds of peanuts. That sounds like a pretty good deal. If the price per pound is the same, how much will Shaneka have to pay in order to buy 15 pounds of peanuts? So we have a situation 1, and we're going to do money or cost over weight. Now let's do cost over weight. So the cost in situation 1 is $33 for 22 pounds, and that should be equal in the same ratio of 15 pounds would be how many dollars? So we could set it up like that, and now we could do it a number of ways. Most students in 7th grade are going to do cross product. We know that the cross product of equivalent fractions will be equal. So we'll do 33 times 15 will be equal to 22 times x. Now a lot of students would multiply 33 times 15 and then divide by 22. I don't have a calculator with me at the moment. I may in 2 seconds, but I'm going to do that. And that gets x by itself because 22 is multiplying by my unknown. So the inverse of multiplication would be dividing. And now I can cross cancel this. 11 goes into these each, and now I have 3 times 15, which I do know in my head, which is 45 over 2, because 3 times 15 is 45, 2 is in the denominator, and now I can divide that. That's going to give me 22.5, so it's going to cost me $22.50. I didn't need a calculator because I made manageable numbers. What a shocker. So if, you're going to have to be able to do math without calculators, on the reasonable problems. There are some where we may have to use a calculator, but for the most part, you want to get well-versed in practice not using a calculator. And when you don't use a calculator, you have to use logic in your calculations, and you have to use fluency tricks in order to make numbers smaller. Don't make them bigger. Find ways of making them smaller. All right, the graph of the line y equals -2/5 x minus 2 is drawn on the coordinate grid below. Which table of ordered pairs contains only points on this line? Okay, so let's see. So we could either plot each of them. That's probably we have our x-axis, coordinates are x comma y. So let's start checking them. Let's look at -5, 0. -5, 0 is right here. So that worked. 0, -2, 0 on the x, -2 on the y. That worked. 5, -4, 5 on the x, -4 on the y. That worked. And 10, -6. Well, we don't have that one because it goes off the chart. It stops at 8, but that's pretty good. Let's look at B. -5, -5, -4. No, that would be -5, -4 takes me to there. That's not on the solution. 0, -2. Yes, that worked. That is on the chart. 5, 0. Nope, that doesn't work. 5, 0 is here. 5 on the x, 0 on the y. That's not going to work. 10, 2. No, 10, 2 is going to be up here. That's not definitely. This one looks like 10, -6, right? If we extend it out, 10, -6, 8, 9, 10, -6. Yeah, that could be there. You know, that looks like it. So C, -2. -2, 2. -2, 2 is there. That's no. 0, -2. Yes, that worked. We know that one is correct. 2, -6. 2, -6 is there. That's a no. And 4, -10. That's down here somewhere. That's a no also. Let's do this one. -2, -4. -2, -4 is there. That's no. 0, -2. Yes, we know that works. 1, 0. So 1, 0 is this point. That's no. 2, 2. That's that point. That's a no also. So the only one that worked is A. But those are good to understand locations. And we see that they do create lines. It's just not the line that has the slope of -2/5 and a y-intercept of -2. So a passenger elevator in the Sears Tower in Chicago. Do you know where Sears used to be one of the most popular stores for to get things. They were very famous Sears catalog. Sears Tower is after the company Sears, which has gone out of business, but it was Walmart. It was like the Amazon. It was the brick and mortar Amazon. You could buy anything at Sears. It was pretty cool. And then they diversified. You know that Sears, I read this yesterday, Sears owned an investment company, like a stock purchasing company, like Schwab, not Schwab, but something like that. And what else did they? They diversified. They were a conglomerate, and they owned lots of things. I forgot there was another interesting tidbit that I don't remember what Sears owned that was very surprising. But a passenger elevator in Sears Tower in Chicago can lift people 960 feet in 1 minute and 30 seconds. How fast must the freight elevator be traveling if it lifts cargo the same height, but in 2 minutes and 30 seconds? Same height, so 960. So here's our height, and here's our speed, and that's in 90 seconds. So our speed has to be in a consistent, and our height needs to be in consistent units. So we have height over speed, and this is situation 1. Our situation 2 is going to be our freight elevator that has to travel the same distance. Pastor, how fast must the freight elevator be traveling if it lifts its car? Okay. Sorry, not equivalent. We know both of the pieces. So this is, distance equals rate times time. D equals RT. Well, rate equals distance divided by time. So distance over time, so that would give us our speed. This is our speed. And so this is going to go a distance of 960 feet in 2 minutes and 30 seconds. And look, it's per second. So we have to convert those. So that's 120, 150 seconds. So let's reduce it to feet per 1 second. And that's where we're going to do it. And so we can reduce that 96 into 15. Well, 3 goes into those. So I'm trying not to use a calculator. 960 over 150. Zeros cancel. 96 over 15. 3 goes into that. 3 goes into that. 32. 3 goes into that 5 times. And 5 goes into 32. 6.6 2/5 seconds. What do we got? Decimals. So 2/5 feet per 1 second. So 6 2/5 is 6.4 feet per second. 6.4. Oh, no way. I can't believe it. So that's how I would do that problem. I would, again, didn't use a calculator, didn't need one. In the sequence below, which expression can be used to find the value of the term in the nth position? So we notice that we are increasing by 1. That's plus 1, that's plus 1, plus 1, plus, well, that's plus n. So that's plus 1. This is minus 60. That's minus 20. This is minus 10. This is minus 6. So we don't see a pattern there. So it's not that it's not exponential, or because most of the times when it's constant on the left and it's not constant on the right, we think that it's exponential. But it looks like are we taking half? No, we're dividing by 2, dividing by 3. No, that would be 20, dividing by 4, 10. Oh, that's kind of cool. So that did work. So if we divide by 2, that's 60, and then we minus it from that. So we take 120 divided by n, and right, we get that, but that's not, and then we take, 120 divided by 3, 120 divided by 4, 120, yeah. So, okay, that's not necessarily a logical way of doing that, but it worked. We noticed, we noticed a pattern there. So that was not easy. That was not an easy. So it's, we'll do that. That works. That's the one. That's the pattern. So that'll give you your nth position. That's not a pre-algebra problem right there. That's a little bit more sophisticated. A circle with a radius of 6 centimeters is enlarged to be a circle with a radius of 15 centimeters. What scale factor was used to dilate the small circle into becoming the larger? So, so we're just going to go 6 times x equals 15. So we're going to divide by 6. We get x equals 15/6, which equals 3 goes in that, 5 halves, so we get 2.5. So a 2.5 dilation. We're increasing it by 2.5. That's kind of easy. We like that. I like this problem. If triangle ABC is translated 4 units to the right and 2 units down, what are the coordinates of point B prime? So whenever we translate things, we don't name it ABC anymore. We now name it prime or double prime or Optimus prime. Just kidding. So we are translating. So for every XY unit, when we translate, we're translating 4 units to the right. So that's left and right are on the x-axis. Up and down is, is the y-axis. And we're going down 2, so that's negative. So if we look at the B coordinate, that B coordinate is 1. Here's our origin. That's kind of important to see where our origin. That's our origin, so that dictates what the B coordinate is. That's going to be 1, 1, 2, 3, 4, 5. So that coordinate is 1, 5. So if we take 1, 5 and we translate it and we put the values in there, we get 5, 3. So B prime is going to be 5, 3. So if we go 4 units to the right, 1, 2, 3, 4, and 2 units down, we get here. Is that 5, 3? 1, 2, 3, 4, 5. 1, 2, 3. Yeah, that's 5, 3, and that would be B prime, the translated triangle. I love, and this is technically geometry, but I like that type of stuff. And I absolutely love spatial relations. The drawing shows the top view and the front view of a solid figure built with cubes. Okay, so this is from the top, and we know that this is void and this is void. So there's no cubes there from the top view. And then from the front view, we have a void across here. So that's interesting. Okay, so which is it? So looking at the front. So let's look at the top. Let's see which one is the top. So definitely can't be that because this only has 2 on the top. That's good, but notice this would need 3 if we're looking at the top view. So it's not A. Let's look at B. B looks good, looks good, looks good. So B is good for the void, right? There's the void right here. And there's a void on the bottom right, so that's good. Now let's look at the front view. Does that look, yeah, I think it's B. Is it B? B looks pretty good. The reason it's not C is because there shouldn't be a cube there, and there should be 3 cubes here from the top view. Same thing here, this is a void, so that doesn't work, and there should be a 3rd cube. So we know that it's not C and D and A, so it's B. Love that. Love the spatial relationship questions. Those are fun. All right. Let's look at problem number 14, a large pulley. Pulleys. Oh, mechanical advantage. That's what pulleys are called. Pulleys are really, really cool on the ratio of mechanical advantage. If you ever get an opportunity, I think it is Destin from Smarter Every Day has a great pulley one. I think Steve Mould, M-O-U-L-D, I think is how you spell his last name, English guy, think that he's got a pretty good one. And I think Vertasium, V-E-R-T-A-S-I-U-M. And I forget what his name is. What's his first name? I think he has one, but I'm certain that Smarter Every Day has a great video on pulley systems. Really cool. A large pulley on a crane pulls 201 centimeters of cable in 1 full rotation. What is the diameter of the pulley to the nearest centimeter? So if it pulls that, that's going to be considered the circumference. And 1 full rotation. So it's really saying, what is the diameter when the circumference is 201? Well, we want to find circumference. Circumference equals 2 pi r, or circumference equals pi d. So we know circumference is 201, we know pi is 3.14, and we're looking for the diameter. Notice the difference between diameter, which goes across, and radius. Radius goes from the center out. That would be the radius. So important to understand those two differences. So we're going to divide by 3.14, divide by 3.14. This one I don't have. I'm not going to know. 201 divided by, we can use pi, the sign, 3.14 equals 63.98. 63.98 approximately equals the diameter. Let's look and see. 63.98, it's going to be 64. Now we could have used 22/7 for pi, we could have used 3.14, or we can use the calculators. Also, the calculator, this is an approximate value because it only went out to that place. So it's not the true value. So it's approximately. So we get A again for the umpteenth time. Which figure best represents a triangle with the sides x, y, and z, in which the relationship x squared plus y squared equals z squared is always true? First of all, this is called the Pythagorean theorem. And the Pythagorean theorem only works for right triangles. So we have to do the right triangles, and it's a right triangle where x and y are the legs and z is the hypotenuse. Z must be the hypotenuse, it must be the longest side. So the sum of the squares of the sides will equal the square of the hypotenuse. So we don't know that x and y is a right angle. We know that there's our right angle, but so it can't be A, that's not good. This is okay, but z has to be our hypotenuse, so that's not our hypotenuse. X and y must be the legs. X and y are the legs, z is the hypotenuse, and it's a right triangle, so that's good. And this doesn't work because we don't know if that's a right triangle. And y is the hypotenuse, is the longest side. That would have worked if we knew that that was a right triangle, but we don't know that it's a right triangle. So it has to be D. D is the only one with all of the information, true information. All right, 16. Carson's algebra teacher drew a line and shaded part of the coordinate plane. Okay, which list is made up of coordinate pairs representing points in the shaded part of the coordinate plane? The shaded tends to mean that it's true, but in this case, they just want to see is 3, -4 in the shaded. So let's look at these points. Let's do this. So 3, -4, 1, 2, 3 on the x, 1, 2, 3, 4. That's in the shaded region. -2, 5, -2 left, 1, 2, 3, 4, 5. Nope. So that didn't work. That's not, both of those are not in. Let's do B. Let's do this in green. So -3, 1, 2, 3, -3 on the x, -4 on the y. Takes me here. 6, 0, 1, 2, 3, 4, 5, 6, 0 takes me there. That's in the shaded. And 9, -2 is going to be something like over here. So that worked. Let's try C. -6, 1, 2, 3, 4, 5, 6. +3 takes me there. 1, 6, 1, 2, 3, 4, 5, 6 takes me there, and -2, 1 takes me there. So that's no, none of those worked. I didn't even do The other one, -6, -3. Let's do the other yellow, sorry. -6, -3, no, 6, -3. 1, 2, 3, 4, 5, 6, 1, 2, 3. So that would have made it. That was okay. It was just the -2, 5 was no-go. So which one didn't? That one didn't make it. Which one didn't? All three of them weren't in the shaded. And B is okay. And let's do D. Let's do this one. So we'll do -3, 5. 1, 2, 3. 1, 2, 3, 4, 5 is that point. That's a no. 4, 1, 2, 3, 4. 1, -1. That worked. And -5. 1, 2, 3, 4, 5. 1, 2, 3 is that. That's a no-go. So there were 2 that were no and 1 that was. So the answer is B. Yep, I like coordinates. Category 4, measurements. Okay, a paint roller has a width of 12 inches and a radius of 3 inches. To the nearest square inch, what is the surface area that can be painted with one complete rotation of the roller? So when we have this, let's not do it in red. When we have a cylinder, we have, what's that, 12 inches and a radius of 3 inches. So the surface area looks like this. If we looked at that and we unrolled, this is going to be the lateral area plus 2 base areas. This is the base, that's the top. This is the base area of the bottom. And then this is our lateral area. So the lateral area equals length times width. Area equals length times width. Now the length of it is going to equal the circumference, 2 pi r. And then the width is going to be the height. So the height in this instance is going to be the width, which is 12. And then the length is going to be 3.14 times the radius, which is 3. So if we want to find the area that it's going to do, we're going to do 2 times 3.14 times 3 times 12. So 2 times 3 is 6. 6 times 12 is 72. Times 3.14. Let's not multiply in that way. 3.14. So that's 8, 2, 6. 7 times 4 is 28. 7, 8, 9, 21, 8, 10, 16, 2, 2. We have 2 decimal places, 226.08 inches, squared inches. 220, what did I say? 226. Yeah, 226 inches squared. Good, approximately. A sponge is in the shape of a cube with sides of 3 inches. So we've got a sponge. And 3 inches by 3 inches by 3 inches. What is the best approximation of the surface area of the sponge? Well, we know that a cube has how many faces? So it has a front and a back. It has a left and a right. It has a top and a bottom. So that is going to be 6 faces. And each face is going to be equivalent, right? So if they're a cube, we know that each face is going to be 3 inches by 3 inches. So area equals length times width. So 3 inches times 3 inches gives us 9 inches squared. And we have 6 of them. So we're going to do 6 times 9 inches squared, which gives us 54 inches squared. 54 square inches. C. So that's a nice way of figuring that out. you can do surface area, which equals lateral area plus 2 base area. There's lots of different things. And the lateral area is going to involve the perimeter. So with a cube, it's relatively easy because we can see that the 6 faces, but there's lots of different ways. That's how I just thought of it. I think in my detailed answer key, I did the surface area equals lateral area plus 2 base area. What is the minimum length of bricks that Chase needs in order to divide his garden? What? Oh, I didn't read the question, sorry. Chase has a rectangular garden, which is 5 feet wide by 12 feet wide. He wants to divide the garden into 4 sections by running a line of bricks down both diagonals of the garden as shown below. So we need 2 of these lengths. Okay, we need 2 of those lengths. So we need bricks that long and that long. What is the minimum length of bricks that Chase needs in order to divide his garden? Well, I guess we're going to use Pythagorean theorem, and it's going to be very interesting because we're going to overlap in this area, and I don't think that they took that into account. But we have a right triangle, remember Pythagorean theorem, and this is 12, this is 5, and we want to know what the hypotenuse is. So we're going to do 5 squared plus 12 squared equals the hypotenuse squared. 5 squared, 25. We should know our squares up to at least 12, if not 20. And 144, 8 squared, that's going to give us 169 equals h squared. So here we're going to do the inverse operation. Thinking about inverse, when we have a math problem, like an unknown plus 2, the inverse would be subtracting 2. How do we get the variable by itself? So think about it in this way. If we get x plus 2 equals 10, we utilize the inverse operation. What's happening to the variable? 2 is being added to it. The inverse of adding 2 is subtracting 2. And then we're very familiar with 3x equals 15. What's happening to the variable? 3 is multiplying it. What's the inverse of multiplication? Division. So we use the inverse operation. Inverse operation is really, really important. Inverse of addition is subtraction. Inverse of subtraction is addition. Inverse of multiplication is division. Inverse of division is multiplication. What is the inverse of squaring? The square root. What gets rid of a square? Is the square root. The square and the square root will cancel each other, much like addition, subtraction, multiplication, division. And so you get the square root of 169. Well, that's a perfect square, much like you should know your perfect squares. So that equals 13. I don't want it in red. 13 equals h. So the hypotenuse of each of these is 13. So 13 times 2 gives you 26. But it can't be 26 because they're going to overlap. Boo! Some of these problems are a little lazy. So that is not the minimum. A minimum, that would be the maximum they would need. And that's just the length, not the number of bricks. But it's all right. Number 20. Almost done. We got 8. Nope, we got 9 more. Parallelogram. I don't like this. It's similar to parallelogram TUVW. When we say it's similar, and you say ABCD and TUVW, you are telling me that A corresponds with T and B corresponds with U. That is a horrible notation. This is not true. It is actually what they wanted to say is that A corresponds with W, B corresponds with T. They're making a really, really bad assumption. A with T, and that's not the case because that's not what we know. It's not. It's actually what they're saying in this shape. Right? Well, let's see. 15. Well, let's see. Let's see if that worked. Sorry, so AB is to WT. So we would know that this is 10. Let's see what's going on here. This is 10 and this is 15. So these two should be proportional. So 15 is to 10. This is A, B, C, D, and this is T, U, V, W. And so that would correspond to 8 is to whatever that BC is to BC. And we'll call this X. Okay, so does that work? Does that work? 15 times 8 equals 10 times X. We're, again, not going to multiply. I'm going to reduce that. 5 goes in this 3 times, goes in 2, and then 2 goes into 8, 4. So 12 equals X. 12 units? Oh, maybe. Hold on. Similar. A is to T. Yeah, but A, it says A is to T, and that's wrong. So A actually corresponds with W. So this is a horribly written problem. They made a really, really bad. It is A to W, B is to T. So this is not written properly. And the way that you would write it is A, B, C, D is similar to parallelogram, and we would say W, T, U, V. That's the proper way to write that statement. And you should know that after 7th grade because you did some angles and proportions and all that stuff. Similar. Rectangle STUV is similar to rectangle LMNO STMN. Yeah, so this works. This is good. So we notice that S is to L, S is to L, T is to M, T is to M. All right, if the area of rectangle STUV is 60 square units, what is the area of the rectangle LM? So this is a little bit tricky because we need to understand that when we do area, so area of the rectangle STUV is 60. So area, whoops, let's do it in this way. Area equals 60. So area equals length times width. So we know that the area is 60, the length is 12, and we're going to figure out the width. So we're going to divide by 12, and we get 5 equals the width. This is one way of doing it. 5 equals the width, so that equals 5. So now we could also do proportional. So we can do 12 is to 5, that's the length is to the width, and if they're proportional, 18 over X. So we can do that, and we can cross product. 12 times X equals 5 times 18. 12X equals 5 times 18. I'm going to divide by 12. I'm not going to multiply 5 times 18 yet because I'm going to reduce. X equals, and 6 goes into 18 3 times. 6 goes in that, and we get 15 over 2, which is 7.5. And now, so this is 18, this is 7.5, and then we can multiply to get the area, the new area. So area equals 18 times 7.5. Let's do 7.5 times 18. 8 times 5 is 40. 7 times 8 is 56, plus 4 is 60. 1 times 5, 1 times 7, 0, 5. 1 decimal place, 135. 135 units squared. That's one way of doing it. We can also find the scale factor, but when we go from area, you have to square it. So you see that in my detailed answers. So a little bit different in the detailed answer technique, which you're taught both ways. in 7th grade that the scaling factor, so area is squared, volume is cubed because you're increasing it 2 dimensions in area, 3 dimensions in volume. Very important concept to understand. 22. There are 2 cubes of different sizes. The larger cube's edge are 3 times longer than the smaller cube's edge. The volume of the large cube is 1,728 cubic feet. What is the volume of the small cube? Okay, so again, since volume is cubed, is 3 dimensions, so we're gonna let's do this. So there are 2 cubes of different sizes. The larger cube's edges are 3 times longer than the smaller. The volume of the large cube is that. So this is going to be the large, and volume equals the side cubed. So if the volume is 1728 equals s cubed, how do we get rid of a cube? What's the inverse of cubed? Is a cube root. So we're going to take the cube root of 1728. That one you shouldn't know. 1728. We're going to do the cube root is 12. So 12 equals the side length. So the side length of the large cube is 12 by 12 by 12. And the large cube's edge are 3 times longer than the smaller cube's edge. So here's the small cube. And if that is x, and it is 3 times larger, so 3 times x equals 12, divide by 3, divide by 3. So the small cube's edge is going to be 4. And what is the volume? So again, the volume equals a side cubed. So this time 4 cubed. 4 cubed, you should know some cubes. That's going to be 64. So 64 cubic feet. Nice. Oh, that's a good one. That's really good. You can also know that volume is proportional, and you would find the cube of that. You could do that little technique different. Data analysis, statistics, and probability. Mrs. Jones tosses a coin 4 times in her math class. What is the probability that she will get exactly 1 head and 3 tails in any order? So we can flip. What are the potential outcomes? So the possible outcomes are heads, 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 heads. We all agree, right? That could be one of the, when you toss a coin 4 times. You can get heads, 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 tail. You can get heads, heads, tails, heads. You can get heads, tails, heads, heads. And you can get tails, heads, heads, heads. That is when you have 1 tail. Well, if you got 2 tails, you could get heads, heads, tails, tails. You can get heads, tails, heads, tails. You can get tails, heads, heads, tails. Did I move that across? Yes. Oh, and then you can get heads. I don't know. Did I do that? How do I do that? Heads, heads, tails, tails. Oh, you can get tails in the middle. I don't know why I didn't do that one. And you can get 2 tails and a heads. I think that's 2, 4, 5. One more. There's one more there. Heads, heads. Oh, I didn't do it very systematic. How? I'm going to do it a different way. I like a pattern. Heads, heads, tails, tails. I'm going to move the heads through. Tails, heads, tails, heads, tails, tails, heads. And now you can get tails, heads, heads, tails. And you can get tails, head, tails, heads. And then you can get tails, tails, heads, heads. There we go. That's a whole lot more easier, 2, 4, 6. And then the other one would be, that's 2 tails. How about 3 tails? So you can get heads, tails, tails, tails. You can get tails, heads, tails, 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 heads, tails, 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 heads. And then you can get all tails. So what is the probability she will get exactly 1 head and 3 tails? 1 head and 3 tails. There are 1, 2, 3, 4 successful outcomes out of, there's how many possibilities? There's 1 here, there's 4 here, there's 6 here, there's 4 here, there's 1 there. So that is 10, 16. So 4 out of 16, which reduces to 1/4 or 25%. 1/4, so my answer is going to be B, 1/4. That's combinations, probabilities, all those fun things. A random survey of semiconductor chips coming off an assembly line shows that 3 out of 500 are defective. If 80,000 chips came off that assembly line today, what is the best estimate for the number of chips that are defective? So 3 out of 500 is equivalent to how many out of 8,000? We're going to cross product, 80,000. And again, instead of multiplying 3 times 8,000, then dividing by 500, let's just divide by 500. And let's cross out some of these zeros. And now let's cross out the 5. The 5 goes into 800. 5 goes 1 times. 5 goes into 8 once. 36, 0, 1. And now we're multiplying 3 times 16. A whole lot easier. 16, 3 times 160, 0, 18, 480, 480 defective, 480. So we would expect that 480 of those 80,000 would be defective. A farmer sold 200 watermelons. He recorded the following data about those watermelons. Which measure of data could be used to calculate the weight of an average watermelon sold? So this is very interesting. I don't know why they went with median. It makes no sense to me. The measure of data. So these are the weights. So the range, that's the high to low. This number is silly. We don't care what the difference between the low and the high is. Low to high would be considered the range. If it's 13, that doesn't tell me anything. The median, now the median is good because I know the total weight. So if my median, if my median is middle. So middle has nothing to do with it either because the middle value doesn't give me the average watermelon sold. The median just means the middle. So I could have, I can have 10, 10, 10, 10, 10, 10, and then I can have 30, whatever that, if that gives you, here we go. And let's do this, sorry. Let's do 1, 2, 3, 4, 5, 6. And the middle is going to be this. Let's say that that's 17.8. Let's do a couple more 10s and a 30. So the median is that. That doesn't tell me that that doesn't really represent the average weight of the watermelon. So that's horrible. This is the one that I would say. I would say the mean. And the mean is going to be 200, right, times 18.5 would give me the total weight. So, I don't know. And then the mode. Okay, mode's not bad either. I don't mind the mode. Mode would have been an okay answer also. But there's just not enough information here. It sure as heck isn't the median. That is the one, and it sure as heck isn't the range. I would be okay. Now mode is most frequent, right? It's not 10, so maybe I don't like mode. Mode doesn't really reflect it at all either, because mode would be 10. Is that, well, that is reflective, so mode would be okay. Yeah, maybe mode, maybe. I'm bringing you back into the equation. But I would probably say the mean. The mean is the average. So to me, that's the best representation. But you want to know, it's so hard. It's hard when you only are given. So maybe using that information, I don't know. I mean, you can derive some information. I think the mean is better. So, but who knows? 26, that's a crazy question. 26, the scatter plot below shows the weight of Miss Carson's students as a function of their height. So based on the information in the scatter plot, which statement is a valid conclusion? The average student's height is more than their weight. Their height is more than their weight? No, we have no idea. No, I don't know that. But I mean, if this is 0, we don't know what the increments on the height and the increments on the weight is. We know no information on that relationship. The average student weighs more than Miss Carson. Have no idea what Miss Carson weighs, nor what these average weights are. As the student's height increases, their weight increases. So as we move this way on the height, are we moving this way? And yes, we are. So that's okay. I don't mind that statement. As the student's height increases, their weight decreases. That's a no. Those numbers do not decrease. As we move right, we actually move up in weight. So I would say that it's C. The table, they made a bit of a mistake on this one too. The table below shows the number of students in each grade at Masonville Middle School who participate in various sports. Which graph represents the data below? So all of these are middle school sports. So middle school, you're going to total all these up. So the total is going to be 30. Not red. So this is going to be 30. This is going to be 91. This is going to be 33. And this is going to be 60. And the total is 214. Okay, if we add all those up. So number of students. So if volleyball has 30 students, that's okay. That kind of looks like volleyball is 30. Football is 91, 60, 78. Yeah, that looks good. Softball looks like it's 30. Yeah. And track looks like it's, it's not 40. That's a no-go. So this didn't work. Track is 40. So track is supposed to be 60. So that doesn't work. These are percentages. So these, when they're done in this fashion, it's going to be percentage. So this says that football is the largest participant. Okay, that worked. So football is larger. Volleyball and track. Volleyball and track volleyball and track are not, they're about the same. But volleyball and softball are the same. Volleyball and softball are the same. So that's not good, because volleyball and track, that percentage looks like these two slices are the same. Softball is more. But softball is not more. Track is more. So track is off. That doesn't look proper. And we're again proportional. Softball and volleyball are the same. Yeah, that's good. Softball and volleyball are the same. Track is bigger than softball and volleyball. That's good. But my issue is that volleyball is more than 100%, or more than 50%, because half of it, right? That would be 50%, but it's 90, 91. So this is smaller than half. So this doesn't make sense either. That's a bad representation. And now let's go over here and look, and volleyball, says that it's 30, so that's not correct there. Football was 91, that's okay. Softball is 33, that's not 33, and track is 60, that's okay. So that doesn't work either. So none of them are the answer. I'm assuming they wanted C, but that's not correct. So football is less than 50% of the total, so you can't have more than 50% of the pie. That makes no sense. Bad problem, Plainsville. No, Praireview. Cell phone company surveyed 100 girls aged 12 to 16 about their preferred cell phone colors. The results are shown in the table. So 34 students liked pink, 32 liked purple, 17 liked red, 17 liked. If the company uses only these data to order new cell phones, which conclusion best reflects the data? 2/3 of each order should be pink and purple phones. So if we add those all together, that's 66. 66 are pink and purple out of a total 100 girls. So that's going to be, approximately 2/3, right? Yeah, 2/3, 66 over 100, 2/3. 2/3 should be, we're okay. More than half of each order should be red and yellow. No, that doesn't represent half. That's, what's that? 34 out of 100 is not half. That's 34%. That's no. Half of each order should be pink phones. The other half should be purple. No, that's not good. Because we have red and yellow, that's a percentage. 1/3 of each order should be red phones. Another third should be yellow phones. No, because that would be a third and a third plus 2/3 does not make 100. So that's not true either. So that's your thinking there. And that's the answer key. Woo! That was a long video. That was a little crazy. Oh, I got to go pick up my daughter at work. Alrighty, have fun. Enjoy. First video.